ipv4 static routing, kind of boring, right? We want dynamic things to take place. But in this network, especially when we have a small enterprise like this, static routing really is the way to go, because we're able to provide not only a primary path to get to networks, but a secondary, and without all of the dynamic routing overhead. So it's very simple. First and foremost, you must have a valid topology of your network so that you can tell what networks are not directly connected to a particular router. So we're using R1 right here, and for an example, R1 has this network. It is not directly connected. And we can look at the topology and see there's another network here that's not directly connected. And finally, we can look over here and see two networks not directly connected. So what we'll do is we'll consider that all of these are 1024K. So we know that all of the speeds here are the same, because that could make us decide to take a different path if we had varying bandwidths. But in this case, we have all the same bandwidths. So first and foremost, we need a route for at least 4 networks. Here's one right here. Here's number 2, and here's 3 and 4. Okay, so first we can see to this network, I should use this as my primary next hop router. But we can also implement a floating route over here to this next hop and use it for my floater for this very same network. We can also use this as our next hop for our primary for these two networks, and this next hop as a floater. Finally, we have this network, and neither next hop is any more desirable than the other, so we'll write both of those as primaries. Once you get done with that router, then just look at each individual router and look at the networks he is not directly connected to, and then do a show IP route static and validate each one of them in the routing table. And you should do that with all of the routers by the time you get through. So we'll go back and configure R1 with a primary route first for this network. IP route, the network number, the subnet mask, in this case a 24, and the next hop, which will be this network address here. So we'll give it 192.168.0.1. Now we'll write the floating route for this same network, but that floating route will point to here. So we'll just recall the same route statement that I previously had, but we're changing the next hop to 6, and to make it a floater, we'll do space and give it an AD higher than the default static route AD of 1. And if we have multiple other paths to that same network, we could continue increasing the AD to give us the next desirable next hop should the primary or perhaps floaters fail. So that takes care of that network for both a primary route and a secondary route. So now we'll work on these two, or we'll work on this network. It's special. Neither this way nor this way is any quicker than the other, so we can set it up for both primary routes. IP route, that network number with the subnet mask, one next hop, and then recall and just give it the other next hop, and that will now be a load balanced route. It will drop both of these routes into the routing table as primary routes. Finally, we have these two networks here, and this will be our primary next hop, and this will be our floater. There's the primary, and the floater will be 1, and ensure it's a floater by assigning it a 2. Then we'll write the other network. Again, the primary is .6, and we'll write the other route again with the secondary of .1, give it a AD of 2 or higher, and then we need to validate these routes. Show IP route static, and we want to count each one of these and validate that they are going to the proper next hops. So again, this router should have 1, 2, 3, 4 routes. We'll check this one first, 172.16.00.24. We'll check this one next, and it should be dual entry. So there's the 8, and it's dual entry. So that means it is load balancing. And then finally there should be 2 for this via the .6, and both of those are correct. Last but not least, if you will notice, the 2 and the 3 networks are what we call contiguous networks. So we can reduce this route table entry to a single entry of 172.16.2.0, and instead of a 24, we will give it a 23 for a range of 2, which will then give us both the 2 and the 3 networks that are depicted in this example. So we simply go over to the router, and we remove those network statements for the 24s, and we remove the next hop for that statement. And I'll remove the second one, the 3. Now I'm just removing the primary route. I'm not doing anything with the secondary, though I would want to go out and also do the secondary. Now I can add it back, starting at 2 with a subnet mask of this time a 254, which is a range of 2, and when I show IP route static, now you will notice that those 2 and 3 networks are now no longer there from a standpoint of that route. But because we still have the floating routes, we need to remove those as well and change them to a single /23. So I'll finish that up. We'll remove the floating routes. Gets rid of that one, and we'll get rid of the 2 as well. And we'll write it again as a floater, but this time covering a range of 2 networks. And the floater will be 192.168.0.1 and give it a floating AD of 2. And now my route table should be clean. And you will notice now we have the 172.16.20.23 network via .6, and that route includes both 2 and 3. We also have a 192.168.0.8, and because it's being load balanced with 2 primary paths, you see it in here twice. And then finally we have this 172.16.0.0 via .1 with a 24. You should go around to all of the routers and ensure that they have primary and floating routes. So for this router up here, again, he'll have 2 primary routes for both of those networks, but they should both be combined from 2 24s as well into a single 23 like we did on R1. He will also, R0, have a route load balanced to this network, one via this network net and the other via that next hop. And finally, he'll also have a primary via that for that network and a secondary via that. So just make sure you go around and do a show IP route static and check off these networks that they should have, and you can simply look at your topology and it should be every network that he is not directly connected.